Hi everyone. This is going to be a fundamentals tutorial for Archimatix, and fundamentals is where we talk about how basic shapes are made and kind of rethink the ruts that we've fallen into. So you're not making the same model every time, and also so you're thinking about how to make models more efficiently and smarter. So in this video, I'm going to compare how to make really large models, like the kind of models that are so big that they're basically the basis for your level design. Um, Now, I'm not going to flesh this into a full scene. That's kind of for you to do. So in these fundamental tutorials, I'm just going to make simple models with just a few nodes. So the goal is, I'm not really trying to impress you with my art. I'm trying to get you to understand these engineering concepts and how to wire up your Archimatix graphs. Okay? So one of the big problems with making like an enormous model that is basically like your entire scene design is how to break it down into smaller parts so that Unity can display it properly. And what I've got behind me is, this is like Robot Kyle. He's in maybe a crazy city or a canyon, but this is all one model. But you can see from Kyle's scale, this is a huge model that won't be on screen ever, not in its entirety. It needs to be broken down into smaller parts, and I think you can obviously see what are the smaller parts right here. But what is more important is that this model is constructed to be parametric, to follow this shape. So I can, build, if I have a basis for level design, I can jump in here and, edit my flow shape. And Archimatix is going to be able to, reuse these big scene models, but, I can infinitely alter them as the scene needs, right? And they stay copacetic, so I have a lot of design choices. Well, let's get into it. So what I'm going to show you, let me turn this off. What I'm going to show you first is I'm going to show you 4 models, and they're all basically, the same. They're all basically variations on the same model, and this is just going to be like a tunnel. All right, I think I have Robot Kyle here for scale. Yeah, here he is. All right, so let's just say that we need a tunnel or a tube, or, maybe this is like your endless runner game level. I don't know, whatever you want to do. But the point is that this model is so big, and you'll either be inside it, or it's so big that it would, wrap off the camera. And let's talk about different ways and different control parameters that these different models offer. Okay, so let me just show you really quick how these models have the same that same kind of flow control. All four models are being controlled by the same flexible plan, and they fill in a little differently based on how they're constructed. So the main takeaway for this video is that you're going to see how to build the same shape, but in 4 different ways, with, you know, exposing different parameters along the way and different controls. Okay? So I'm just going to blank this out again and start completely fresh. Now you're going to see, you're going to see that I have a lot of nodes here in my graph that don't come with Archimatix. Now some of these I've put up on community.archimatix.com. There is an AX share where I put up some free nodes and free models to, you know, to get you started. But really what you need to do is start diving into TurtleScript so that you can make your own nodes and your own shapes and your own controllers. That won't really be in this tutorial, but, you know, I can't state enough that to get control of your models, you really need to be making your own nodes that you can control in exactly the way that you design. Okay, so I'm going to start with what every Archimatix model starts with, which is a section and a plan. What's going to be my plan? I have this big Bezier ramp. That will be my plan. And I know when you're thinking section and plan, our first go-to mesh creator is, where are you? You know, Unity just upgraded everyone to this dark mode, and I can't find any of my icons anymore. It's too different for me. Okay, so Plan Sweeper is probably your go-to. You know what, let me shrink down so I'm a little less distracting. Okay, so probably Plan Sweeper is your go-to 3D mesh node. And I'm just going to wire it up. So we have a section and a plan. And what did we end up with here? Okay, so you can see right away that really simply I have that same control. This is my Bezier ramp node that I wrote, and it's just convenient. It gives me these scene handles to control this kind of like big curve shape. So now, no big surprises here. I'm sure you've all used this node. But the problem in using this as one big tunnel, you know, and I'm just going to take a few seconds here and flesh this out so that we can see this a little bit better. I'm going to turn my tube, my section shape, just give it a little bit of thickness. And I don't need the top cap or the bottom cap. I need the end caps. And let me just slide my section shape up so it's not sitting below the ground. Okay, so now what we have is this tunnel or tube, and it's all one piece of geometry. In fact, let me just turn on our shaded wireframe so that we can see how this model is being built. And my controls for how this model is being built are basically in the segs parameter of my section and the segs parameter of my plan. And, you know, depending on what nodes you're using, of course, this will be different every time. But you see that I have segs here, and I can dial this down. So it's using just the minimum number of, what should we say, 3? It's going to keep that curve shape, but you see I've reduced my section polygons. Now to reduce the length polygons, that's in the segs control on my plan shape. So you see I can hold on to the basic S curve of my Bezier ramp, but I can, you know, I need to really like dial up the segments that my path is being created from to get a really smooth looking pipe. So I'm going to put it at something kind of medium. I'll do 24 segments. Okay, so that's a pretty reasonable curve. And when you look closely, you can easily see how it's constructing this shape. And you can see, even though this model is like, you know, it can be like the size of a city block. Like, let me just, you know, pull this way out. Now, no matter how I deform this shape, notice down here my vertices and my triangles are not changing because I've set a hard number on how many vertices this model is going to contain. And those two settings are the segs on my section and the segs on my shape, on my plan. Okay, you following so far? So one of the problems with having such a huge shape like this, even though it's not a high polygon model, is that Unity can't cull any piece of this shape. And, you know, Unity loves to simplify things. So it kind of like prioritizes the 0 point, you know, your transform position of the shape over the actual polygons and surface normals. So depending on what you're trying to do, this shape is really easy to control. Obviously, it's just, you know, 3 nodes here. But this is not necessarily the best situation for Unity, especially if your character is at the scale of, you know, little robot Kyle. All right, I'm going to show you also there's another problem, which depending on how you're building your path plan, in my case, you know, this is my Bezier ramp node, and I just used turtle logic to kind of expose a basic Bezier command. Which is right, you know, it's just basic turtle logic. And then I did some elaborate tricks to get the scene handles to work. But the problem is, I don't know how long I don't know how long this shape is. Like if I am trying to plan out like an endless runner, or I need to, you know, build this environment parametrically. This particular node allows me to set my start position and set my end position. So those are known XY coordinates. But I can, you know, once I start sliding around my Bezier controls, I don't actually know how far my character needs to travel. You know, so if I'm going to place like obstacles along this path, or I want to estimate how much time it's going to take for him to walk this entire path, I have no reference. I have no parametric output. You know, like if these positions are really close together, the line is a lot shorter. Okay, so not super helpful. Easy, but not super helpful. So what I'm going to do is I'm going to build this same tube another way, and I'm just going to slide this over. Actually, I'm gonna jump in here and set its transform so it's like out of the way. Sure, we'll just slide it up there somewhere. Okay, another way that we can create this shape is with an extruder. So I'm going to put my section into the extruder, and then I'm going to use a plan deformer. And it takes a little bit more setup, but it's not that many more nodes. It's actually just, you know, one more node. No, why don't I see you? Now, let me extend my extruder. And looks like the problem is, oops, sorry, I'm on two different desktops. So the problem is that my extruder is pointing off in one direction, and my plan deformer is pointing off in a different direction. So I'm gonna fuss around until I can get them very simply aligned. And I'm just gonna use this. I'm not sure which one it is. Now the one that didn't align as expected is because it's being deformed off at a strange angle by this plan deformer, but we can't really see it bending because I haven't put in any. I need to subdivide this mesh with my segs parameter here. So I'm going to dial in some extra segments. And you can see right away it's starting to curve to match that path. And we're going to see it, you know, look exactly like this curve. In fact, let me show my curve. And what's happening is that my extruded shape, my extruded version of the pipe, isn't as long as the path, but that's okay. The shape still builds, and in fact that might be what I want. But in this case, I can be really exact how long the tube is. Like, just by using my height extruder. Now if I go over, it just continues on. It just continues on to infinity, right? And also if I use my transform, I can slide the model along this shape. So it's almost like a train on a track, right? The track is my plan deformer, and the shape, as long as it has enough segments so that it can deform, is just going to slide along. I hope you're already getting some ideas like what you can do with this. And, you know, the most interesting thing is I can still sit here and edit my plan. And look what the pipe is doing. It's never becoming longer than an explicitly set height on my extruder. Okay? But I do still have this like flexibility in my original plan. Alright, so I'm just gonna build this model one more time. Also you see that on both ends, continuing off into infinity means means that this is going to point in some direction, and you know, you may not know what that direction is, so I'm just going to reduce that. And let me just soften up that curve. Okay, I'm going to slide this model out of the way so that we can build a third model. Where's this one going? Yeah, I'll slide this one. Wait, I'll slide it up. How's that? Okay, I'm trying not to confuse you so you can keep track of which model is which. All right, now a third way to build the model, and remember, this is just such a huge pipe that, you know, it may not really be practical to have one model that spans that much space. So I'm pretty sure we've all played with kind of making it's not a solid model. I want to make sure that my graph stays pretty clear so that you can follow what I'm doing. But to use a plan repeater, and the idea is you're not doing a deformer, you're just going to place shorter segments along with the, come here, along with a repeater. So we need another little extruder, and I'm going to extrude a short version of my section. This time I'm going to route this short section as the node mesh in repeater, and of course the plan is my Bezier ramp. Okay, so you can see I'm approximating the shape of the two, but you know, everything's pointing in the wrong direction. So let me just fix this. Basically, my original extruder needs to be realigned, And what you see is, yeah, this is still the same shape. There are some advantages to doing this. For instance, if your little extrusion shape, now I'm still using the same, the same little tunnel section. But if you're using prefabs, like you have little houses, you have, wall parts, you have dungeon, blah, 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 right? And you want to space these things out. Yeah, this is kind of the way to do it with a plan repeater. So we have some other controls here, and I'm just going to make this a little clearer. The default extruder comes in at like 2 meters. I'm just going to reduce it to 1 meter so we can really kind of see how this is chained together. And the default control on my repeater was also set to 2. And I'm just going to leave it at that for now. But, I can reduce it down to like 1. So if this matches, if the height of your extruder matches the bay width of your repeater, you can get pretty close to like a segmented version of the same tunnel, but it's made out of separate pieces. Unity can call these pieces. In fact, these pieces can be, if you have like a GPU instancer, these can be instanced by the Unity engine. So there's a lot of advantages to why you might want to do this, but as you see, it doesn't always handle these curves any better than the basic mesh. Like here I've got a break, that's going to like, basically leaves my pipe wide open, right? But as game mesh, where it doesn't have to be photoreal, it just has to be kind of suggestive of where we want to control the path. This is fine. This is pretty cool. It's always valid to kind of make a suggestion of architecture rather than doing actual architecture, especially in a game that is more stylized. You can easily get away with, putting in a skeleton or some kind of suggestion that represents architecture instead of a photoreal architecture. That might not be your goal, but it's valid. All right, so I think you know how this works. This is no big surprise, right? I'm going to show you a 4th way to make this model. And again, let me just slide this over using transform. Okay, the 4th model, we're going to build on this same idea of using a segmented version of the tunnel. So we're just going to build it out of small segments, but I'm not going to use a repeater. Well, actually, I am going to use a repeater, but again, I'm going to make a slightly more sophisticated version of this model. Oops. Now I just want to grab my short little extruder. And this time, I'm first going to use a linear repeater. And I know you think this is like a little odd and a little elaborate, but there are a lot of advantages to doing exactly this. Don't worry, I'll show you. Again, hooking up my short segment to the node on the repeater. And don't worry about it following the Bezier curve just yet. Now, on this linear repeater, I don't have the expected controls down here in controls. Instead, I have a, whoops, here you are. I have a repeater tool. So remember our repeater distance. Here the equivalent is bay. And I'm just going to shift it down to 2 or maybe 1. And I'm going to send the size of my repeater way up. Now, one thing you got to be aware, this repeater tool is growing from the center, and our other models grew asymmetrically. This one's growing bisymmetrically. This is a big issue in Archimatix when you're doing parametrics. Some things grow from their centers, some things grow from their ends, and you always have to correct for that. So what I'm going to do is I'm going to correct for that. And you see, it's really just a matter of tying this X translation to this size. So I'm going to connect these parameters with a behavior or a relation. What are these called? Relations, I think. And I'm going to drop in a little bit of math. I'm going to say this is divided by 2. And I don't want it to feed back, so I'm just removing the return chain and saving it. Now my size, look at that. Okay, I'm growing my model from the end. All right, now I need the linear repeater to have its own plan deformer. So the input mesh is the linear repeater into the plan deformer, and of course my plan is my Bezier ramp. So let me just connect that. Now again, I have a similar control to the extrude length, where I can control exactly how long this tunnel is using the size. And again, when I run out of plan, I just continue on into infinity. So I have a really specific control. But this is even better than you think. So this might look like a more elaborate way to just do a repeater, but this model is the most sophisticated version. Now let me show you why. My little extruder is currently at 0.5, but I'm going to make this height on my short extruder match exactly the bay on my linear repeater. You following me so far? Now what you see is the linear repeater has, made what looks like a solid tube, but it's actually made up of all these little sections. The plan deformer is deforming all of my vertices, so my tube has no break lines. This is a perfect tube. Okay, but it's made up. If you go into the hierarchy and you look at how the geometry is being constructed, this is still a lot of repetitions of this one little extruder, but by using a plan deformer, I have an unbroken model. So now let me just play around with this for a second so that you can compare all of these models together. Now you see they all deform the same, but they each have a slightly different function, and they each have different parameters. So 2 of these models, the tunnel is a specific length, no matter what the plan is. And 2 of these models, the plan determines how long the tunnel is. And the geometry just fills in to complete it. All right, now I'm sure you're wondering why go to such an elaborate length to first construct this out of like small segments and then set it on a linear repeater and then deform it along a path. Well, there's so many things that you can do to manipulate this model to make it like way more interesting than just a tunnel. So let me show you a few tricks. So if we go back to the short little extrusion, there are all these controls, like for instance, the bevels. I'm just gonna bevel out and give it just a little bit of a kick up. Come on, work with me here. Right now you have it like a corrugated hose. I'm not sure what you want to say, but it's certainly a much more interesting looking model. Now, of course, our repeater is also doing this, but the repeater, has some issues around the corners and is dropping in some gaps. But it's still more, it's still the same idea. But here, with our linear repeater through the plan deformer, everything stays as looking like one model, even though it's made out of these segments. And there's other things we can do. We can add tapering, which makes like a... let me take off this bevel. Again, it's making another interesting looking shape. All right, but the other thing is, like I said, where you can, sometimes it's more interesting to imply architecture rather than actually build it. You can leave the gaps in the model by increasing the bay. And it's a little wonky dealing with how this like grows and the sizing happens, but you just have to play around with it. These are all parameters that once you can start controlling it, you can get a real handle on exactly what's happening in your scene and what's being added to your scene. The other thing that makes this model better, that makes this method better, is, for instance, with our repeater, there's no way of knowing, just on the repeater itself, there's no way of knowing how many of the segments got replicated. Like, I just know that it went to the end of the path, but I don't know how many individual units are here. That might be a real problem. Like, these might be specific rooms, these might be sections with their own, like a dungeon enemy. Like, each one of these segments contains, some piece of your game level, and you need to know exactly how many there are. And you also need to control, how far apart they are, how much time it takes to walk from one to the next. On our linear repeater, which is then plan deformed, we get a specific parameter of how many cells how many cells are being created in the scene. So it's really a different way of building the model, but telling you, when you expose these parameters, or you control these parameters externally by script, this model basically tells you a lot more information about what's in your scene. And these are like perfectly spaced. And also, so let's talk about this deformation, how the plan deformer works. I'm going to increase our extrude height to something big, like 4, well, relatively big. So now everything is overlapping. I'm just gonna bump up our bay to the same number, 4. Now, I'm also going to make our tunnel wider. Just to cause us some problems. Now, if you haven't glazed over yet, if you are glazing over, just stop this video and go and build these models yourself and start playing around, because you're going to learn so much more by making this intuitive, by working with it constantly. You'll get a better method and better handle. If you're still with me, I'm going to show you how this model deforms differently. So what plan deformer does is it squeezes the vertices, it compresses them on the inside of the curve, it expands them on the outside of the curve. And if we were to take our original section and maybe just slide it off the curve, this would become even more obvious. You see how as it goes into the curve, it's becoming smaller. As it is on the outside of the curve, the vertices are further apart, right? This is how it deforms. Now, all of these are kind of handling this just fine, but there's going to be times when your model is just getting janked because of this curve. Let me show you one other thing. Some of these models are more affected by the plan segments than others. So remember, way back at the beginning, I had, just a few segments, and that really changes some of the ways that this deforms. Now look at my original. This is the original plan sweeper. Now it's handling this really well. It just breaks the model. Putting in the vertices in line with the plan. However many segments are in the plan, that's how many vertices you're going to get on your model. The next one was the extruder. And that's not how it works. The extruder has a set number of vertices. So the best it can do is, wherever those vertices fall on the plan bend, that's a janky curve, right? Not a lot of control there. Just a janky random curve. Oh, now this one, what's this one? I think this one is our plan replicator, plan repeater, and yeah, I didn't handle this curve at all. So what's our segmented one doing? It's having the same issues basically as the extruder version. But remember, these are separate models, so I could go back in and I can edit this on the straight part. I could make this particular segment smaller. I could, I could do, if these were like, again, like buildings being replicated along a path, I would have some options to how to fix this, but basically what I need is more definition in my plan, of course. So what I kind of want to show you is, this is obviously a compromise between how many segments are in your plan versus how many segments are in your mesh. And let me just jump back and do one more thing. I'm going to take that original extruder and make it even longer. My segment extruder is now going to be like 12. And I'll match the bay. And just for fun, over here on my repeater, I'll match that as well. Where's my repeater? Bay. Okay, it's still not doing it. It's not doing a very good job, as you can see. And now here, my janky path segments are maybe a little, they don't need to be so high detailed, right? Okay, you get the idea. All right, what I want to do next is take the same concept, and instead what I've done is I'm just taking the segmented linear repeater into the plan deformer, and I'll just show you what I'm doing. Let's see. Let me revive the model that I showed you at the beginning of the video. Okay, so now I think you probably have a better idea of what's happening here in this scene, and how I'm manipulating this very big plan. Because basically everything I've done here, I've already shown you how to do. But I've added some little tricks to my linear repeater to make it look a little more complicated. So let me just show you that graph right here. And I encourage you to go build this on your own. Especially if you want to do something really large scale, like a city street. Or, maybe these are canyon walls. You have an endless runner. I don't know what you're building. But, yeah. As you can see, this is, like, very interesting at ground level. Like, each of these blocks is kind of unique. And, if these were buildings, I'll show you a little bit of a video that I made where these were buildings that kind of look like Toontown, a little surreal. That was the idea. But this is not that complicated. Basically what you're doing is into the linear repeater, if I can find where it is. All right, extruded a segment into the linear repeater. I've used my jitters. jitter translation, jitter rotation, jitter scale, and of course I'm controlling all of this with the repeater tool. So by setting up some jitters and, the built-in like Perlin noise and offset, I've got my buildings or my cliff walls, whatever you want to call them. Some are leaning this way, some are leaning that way. Some are taller, some are shorter. I've also subdivided each block, and that is that's here on the extruder, both subdivisions and segs. Now, one of these walls is to the left of my path, and then I made an instance just by going up here to the menu and selecting instance, and that duplicated the same wall, and then in my instance I used the translation and slid it the other direction to the other side of the path. So now I have two versions of the same wall on either side of my path. I grouped those together, so now they behave as one, and I passed it through the plan deformer. Now my two walls in the grouper now deforms along the path, the plan. I keep saying path, but it's a plan. It's not a path, it's a plan. And then lastly, I'm running that entire plan deformer into a noise deformer. So these are just going to be like, a rocky cliff face that's where my, I can exaggerate this deformation, or make these buildings, if they're just leaning buildings, I don't know, however old the walls are, how eroded they are, you get a more organic kind of shape, right? And the whole time, my entire geometry here is really set. I'm not increasing geometry, I'm not removing geometry or creating new triangles. And so I have a really clear idea of, my scene resources. But if I was to maybe parametrically control these curves, I can duplicate these and create, like an entire city labyrinth out of multiple versions of this mesh, placed along different plans and deformed along different shapes. All right. I know this is a little bit long. I hope you followed along. I hope that you, got some ideas, and you're going to start approaching your own models a little more flexibly. See how you can break them down into smaller pieces that you can repeat and manipulate. And I don't know, stay creative. Go ahead, and I'm not sure how important it is to like, because I'm just going to put these on the community. Let me show you one last time. Go to communityarchimatix.com and you can find all of these tutorials. And if you want to subscribe to this YouTube channel, hit the bell and you'll be notified when new tutorials go live. Thanks, everybody. Thanks for watching, and thanks for sticking with it. I hope this helps. I'll see you next time.